I discovered AI through Star Trek. Data was a very interesting humanoid robot, very human-like, but also very computer-like.
Do you think in the future we could get to a reality where it's almost like Star Wars?
There's no future that I can imagine where that's not the case. It's just a matter of time to when we get there. Who could have thought 10 years ago that you can order a paper towel pack online and have it at your house in one day? Like, why would anybody even want to do that?
Yeah.
But people do it every day now. ChatGPT, when it first came out, people were calling for a 6-month pause in the development of AI because it's about ready to take over the world. It's been a good year and a half now. And now people look at the first ChatGPT and they're like, that thing is stupid. Oh, that's garbage.
Welcome to the BeaverHacks Podcast. I'm your host, Havel Konda, and today our guest is Professor Alan Fern. He's a leading researcher in artificial intelligence, robotics, and reinforcement learning here at Oregon State University. Professor Fern is a faculty member in the School of EECS and co-directs the Dynamics Robotics Lab, where he works on developing AI-powered humanoid robots that can perform real-world tasks. He's also the AI director of the AgAid Institute, a national research initiative focused on applying AI to transform agriculture. Professor Fern, welcome to the podcast. I'm really excited to get to speak with you today.
Yeah, thanks for inviting me.
So, just going back, you studied computer engineering at Purdue University, and I guess that's a nice starting off point for our conversation. But yeah, what got you into this field in the first place?
I was kind of lucky. Early on, I discovered that I was very interested in AI. So I grew up in Maine before the internet was widely available, so there's very little information. So I discovered AI through Star Trek. Data, this was the Star Trek The Next Generation. Data was a very interesting humanoid robot, very human-like, but also very computer-like in many ways. And that fascinated me. I had a project in my chemistry class. We had to write a report, and I remember I decided to write about AI, and they allowed that. And read about it in Scientific American and Discover magazine. Like, there were really not many references at that time. Like, what could you find in your library? That was about it. And then that really spawned my interest. And I started learning. I had a computer. I started learning to program. And there happened to be an article in Scientific American about neural networks. And it was deep enough that you could actually implement a neural network just from that article. So I tried implementing it on my own computer. Would just try to have it recognize digits, for example. Go home from school and see if it's trained or not. So that's how it all started. Then I went to my undergraduate studies in electrical engineering at University of Maine and got connected with some professors who were doing some AI-ish type research in the sort of pulp digester level prediction. This was so the paper industry was really big in Maine at that time, and they worked with the paper industry. So was training some neural networks then to predict digester levels. That just kept on, my interest kept growing, went to Purdue University. And then I hooked up with my PhD advisor, Bob Given, he came from MIT, and they had a very different style of AI. It was more, his style was more from the symbolic AI side of things, which we can get into a little bit later, the differences. So I picked up that style of AI and also an interest in machine learning and combining symbolic AI and machine learning, and eventually graduated and just directly came to Oregon State University after that.
So what was that contrast like doing research here at Oregon State versus what you did previously?
Well, yeah, when you're a faculty member, it's very different because you're really running the show at that point. I mean, the beautiful thing about being a research, in research and academia is you can basically do anything, but you do have to get it funded, and sometimes having no constraints on, this idea that you can do anything is really, really difficult because you have to actually decide what to do, as opposed to being a student and you have much more guidance. But, coming here was great. I came here because there was an explicit choice at that time in the School of Electrical Engineering and Computer Science to grow the AI program. It was a small school, like in terms of, the giant schools out there, but it was growing fast. And they knew that to really make their mark, they had to make their mark in particular fields. And AI was one of them. And at that time, there were two other main professors, Prasad Tadapalli and Tom Diedrich, in AI, but they were going to try to grow really fast. And I'm like, yeah, it sounds like a great place to be. And so I joined. Year after that, my wife joined. She's also in AI. And it's just been a really great experience learning from, the experienced professors here. They really help jumpstart a lot of my research. But that's really the difference. You have all this freedom, and figuring out what to do is really what separates the successful professors from the ones that aren't as successful, making those choices.
I know AI is a pretty broad term these days, and a lot of it can seem like hype. Do you want to go a little bit into what your research focused on and what you did?
Yeah. So AI is a broad term, and it's used a lot of times just to, sell companies and, to sell to investors. But as a computer scientist, the way I think about AI is traditionally we know how to create algorithms and programs to solve particular problems. And what we might call this like the traditional programming paradigm, right? We write down the instructions, we tell it exactly what to do. And these systems get so large, they're pretty amazing, but there is traditional programming. And most broadly speaking, I think of the field of AI, because it's so diverse, as trying to deal with problems that can't be approached or we don't know how to approach with traditional programming. So recognizing things in images. I don't know how to write a traditional program with if-then statements and for loops to recognize arbitrary things in images. And so the AI approach to that is very non-traditional in the sense that we wrote algorithms that could learn from images and then learn some structure, which might be a neural network nowadays, to recognize the images. And we don't really understand the details of how that neural network is performing the task. And that's there's a lot of potential problems and challenges with that. But we do understand now more how to train these systems, how to write programs that we can then give data and train. And so that's how I distinguish AI at the broadest sense. It's attacking problems that can't be solved with traditional programming. At least we don't know how to yet. And my own sort of journey in AI, you can think of AI as traditionally, it's really an old field. It started in the 60s, even the late 50s when computers first came online. And people started doing things like building programs to play checkers, right? And that's pretty amazing at first, because we think of checkers and chess as like the epitome of intelligence, right? Human, if you know somebody that plays chess, you're like, yeah, that's a smart guy. And when you get a computer to do something like that, you then all of a sudden get overconfident. You're like, oh, it can also do everything else that humans do, because if you can play chess, you can do anything that a 4-year-old can do as well. Well, it turned out that that's very much the opposite. Today we can get computers to play chess your iPhone can beat Magnus Carlsen, the best chess player, one of the best chess players in the world. Your iPhone can beat the best Go players in the world, which is like the Asian sort of version of chess, you could say. It's that's the type of game it is. And yet we don't have systems that can reliably be handed a broom and sweep up an arbitrary floor, or go around this room and tidy it up. We just don't have those systems, and most 5-year-olds would be able to do that sort of thing. And so it's really been kind of surprising the way that the AI paradigm has evolved, and I think most recently, we now have these neural networks and large language models, and that's been the newest surprise, which nobody saw 5 years ago. If you had asked me that, if you had shown me a picture of what's happening with these language models and how people are interacting with them and what they're doing, I would have thought that was a movie, honestly. Like that's how surprising this was. And it's surprising because the approach to getting there was actually very simple, right? Just predict the next word, but train a model that can predict the next word on the entire internet and using billions of dollars to do that. That just was amazingly a way to get these amazing chatbots that we have today. And I think we're just beginning to learn how to harness this new capability, but it's a very exciting time now.
I think you brought up a perfect segue to, your robotics research where, we do have these models that can beat the top chess players in the world, but they can't really do things that maybe a 5-year-old could do in terms of like physical activity. So that kind of is where your research at Dynamics Robotics Laboratory, where you work with Jonathan Hurst. Mm-hmm. That's where kind of your research there comes into play. Do you want to talk a little bit about that and how your kind of evolution from AI to a more specific robotics, hardware-focused field kind of evolved?
Yeah. And that's been a major transition point in my career, really. So before starting to work with Jonathan Hurst, who's now, he's a co-founder of Agility Robotics and chief robotics engineer. That's a position now there. I was a pure AI researcher. I would try to make AIs that play games, but always in the virtual world. And it was a sort of assumption that, we'll have these interfaces to the physical world and we'll be able to still just play in the virtual world forever. And eventually the physical world will catch up to us. And I just stopped sort of believing in that once I started working in the physical world. So I started working with Jonathan. Jonathan he's obsessed with legged robots, that's in the best sense of the word, obsessed in the sense that that's what he wanted to solve, legged robotics. Make robots that can walk and run and be as agile as human and animal legs. And he was very successful at designing the hardware for that purpose, very much modeling the ideas from animal biomechanics. But the control problem, controlling those legs, getting them to walk, run, skip, was very hard using the traditional robotics techniques. And me as an AI person, it's like, okay, yeah, we work on problems that can't be solved by traditional techniques. And in particular, I was a reinforcement learning researcher, which is a field of AI where you basically have the AI agent, the program, play in an environment, just do things by trial and error, and you give it rewards, positive and negative. They're just numbers, positive and negative, that tell it how good it's doing at any time. And by playing in the environment and getting these rewards over and over and over and learning from those, the agent will try to learn to maximize reward. And so we thought, well, maybe we could do this on the robot. So and we worked for a couple of years with. We started off with an honor student doing their thesis on this. Worked for a couple of years to get that to work, not on the real robot, but in simulation, because you cannot do reinforcement learning on a real robot from scratch if you're trying to get it to walk, right? The first 100 million steps that the robot takes, it's just going to fall. And so you're going to end up with broken robots. And so the approach we ended up taking is something we call simulation to reality, or sim to real AI, which is get a simulation of your robot in an environment and train it there with reinforcement learning. So it can fall for, 1 million time steps, and it doesn't matter, right? It's not going to break. And once you get the robot in simulation to behave as you want, then you put that neural network, for example, that we trained on the real robot, and cross your fingers and hope the real robot will work. And to get that sim to real working took us about 2 years. It was a very hard process. We had to learn a lot. For example, you can't just have a single simulation of physics and then expect that what's learned in that simulation to work in the real world, because the physics simulation is never going to match exactly what the real world is.
Right.
And so that to solve that's just one problem. We use something called dynamics randomization. So in the simulator, we randomize the physics a little bit every trial. So you'll randomize the frictions, you'll randomize the motor efficiencies, the center of mass, and the neural network controller has to learn to be robust to those randomizations. And then when you put it on the real robot, it's more likely to be able to function, because it's seen a lot more variations. And so that's an example of one of the challenges. And so after that process, we got really good at getting the robots to walk. And with more research, we were able to get them to hop, skip, jump, really interesting things. We just kept on pushing the boundaries to see where this sim to real approach will break. So we did a 5K. To get the 5K, we had to train the robot to be more efficient, to step lighter so it's not going to break itself. We then we got the Guinness Book of World Records for a 100-meter dash for a bipedal robot. And for that, we had to train it to be really fast and to actually stop at the end and not fall down, right? And so this sim to real training approach just kept on working. And after a while, we were doing so much with just legs and locomotion, we kind of got bored of that, right? We're like, okay, yeah, now, and you'll see lots of videos on YouTube now where people are having robots dance and just do things. These robots are all blind, by the way, so they don't see anything. They're just like doing motions and they're remote controlled and reacting to the environment. We kind of got bored of that. And we were able to get enough funds to purchase a humanoid. So now we have arms. We can actually start doing things in the world. And that's really what is driving me now. I think that what we're missing now is robots that can actually do real world work. And you don't need robots to be solving chess problems to do real world work, right? We would be perfectly happy if we have just a bunch of zombies, essentially, that we can instruct and have them just not fall down and not do stupid things, not break stuff, and get things done. And so that's sort of what we're aiming to do in my lab now. We're taking this sim to real approach still, but now we're trying to do this in the context of, okay, now we've got vision, we've got cameras on the robot. The robot has to respond to natural language, and it has to do things. It has to pick things up, put them down, not bump into things, not break things, and be safe. And so that's really where we're at now. And we're somewhere along that trajectory, but there's still a long way to go.
So I think on that note, we've already discussed this, but do you think in the future we could get to a kind of reality where it's like almost like Star Wars? We've got all these droids around and then they're just doing these menial tasks for people.
Yeah. I mean, I think there's no future that I can imagine where that's not the case. And it's just a matter of time to when we get there. And I think we're kind of at an inflection point, maybe where self-driving was 10 years ago, perhaps. It's really hard to state timelines here, but there are a bunch of companies now that are starting to have humanoid robot programs. Some of them are just exclusively about humanoid programs, but there's Tesla, Agility Robotics, Figure, and several other companies. And the hardware is there, right? So in our lab, for example, we've built up a whole body controller for the robot that you can teleop. This sound, when you see somebody teleoping a robot, it seems pretty simple, but it's actually very hard because the robot itself has to always be balanced. It has to be able to move its body in arbitrary ways without falling down. It has to be able to pick up something through the teleop controller, and regardless of what weight it is, sort of react and not fall down. So that's hard. But with that teleop controller, you can do a lot of stuff with these robots. And I think other companies are, including Agility Robotics, are demonstrating this. And Agility even has some automation for some of these processes in the factory work that they're working on with collaborators. But the fact that you can get the teleop to do so much says the hardware is there. And really what's missing is the intelligence in that teleoperator, right? We want that intelligence of the teleoperator to now be implemented on a computer. And that's sort of where whoever wins that race is going to be the leader. And I think there will be multiple players in this space. There'll be multiple companies that are all competing, but there's not, I don't think there'll be one company that comes out like completely on top. But whichever companies can master the AI side of this humanoid robot puzzle, they're going to be the leaders in the industry. The hardware is there.
Do you think this is kind of like a separate discussion almost, but do you feel like the progression at which these things are advancing is sort of like an exponential curve where it'll just keep getting faster and faster? Or do you think it'll just kind of flatten out at a certain point?
Yeah. I think it's talking about exponential curves is tricky because what you'll hear people say a lot of times is the exponential curves are more like logistic functions. They go up fast and then they flatten out. And that's a lot of what you see in technology. So it feels like things are moving really fast now, and they are. But right now, I think if you look at language models, the improvement is still there, but that moment where you were just blown away, those are going to be further and further apart, I think, the Chat GPT moment. But I think we're still on a very sharp upturn on this curve. So it's really hard to predict how fast technology is going to progress. But I do think in the next couple of years, the humanoid robots and robotics in general, there's going to be some major advances. We're going to kind of get used to seeing robots doing things in the real world, and you'll get used to seeing fancy demos, so they're not going to be as impressive as today. If you see a robot like opening up a refrigerator and putting things in it, it's like, wow, that's really amazing. That's just going to be like common. That won't be special. But what I'm really waiting for is a day where you see a construction worker, right? That today we have construction workers and they're doing tons of manual labor mostly. And they have foremen that are directing them. What I'm hoping is that we're going to see the construction worker with a team of 10 humanoid robots watching over that team and 10xing their productivity. And that will 10x, the general productivity of all the logistics we do, all the building we do. And that's really one of the bottlenecks in today's society and the economy, how much physical labor you can do. Why can't we build all the infrastructure that we want to build? It's not a matter of like putting money into it. Like there's a lot of money just sitting on the table that's not being spent. And, there are regulatory issues as well that block some of this. But at the end of the day, it is a matter of labor as well. And I think that's where robotics will really, really come in to shine. And the other thing people don't realize is there's also all of this hidden manual labor that we never see. Like our iPhones, they're all built with a lot of manual labor in other countries. And we complain about that sometimes. But how could we not have that? Well, we don't have enough workers here that will work at those wages to do the jobs, but we could have robots do more and more of that work, and have more of our production and more of our industries sort of based, in one's own country, which has a lot of economic benefits.
Yeah, I think we could dive a little bit deeper into the aspect of labor, because I feel like that's something huge where people there's like really unethical practices in certain countries and areas. And the reason why those unethical practices exist is because there's such a demand for stuff, but we don't have enough labor to actually do it. And there's a lot of fear in a lot of markets that, oh, we're going to get like replaced by AI. But I feel like what you're saying is completely contrarian to that, where, you know, rather it could just elevate us further, you know. Would you like to dive deeper into that kind of that?
Yeah. And you know, these things are, I'm not an economist, but there's always two sides to a story. So you know, there's a lot of fear, and fear sells. That's the first thing you have to remember. Whenever somebody's trying to scare you, you always have to think, okay, what are they trying to accomplish? You know, a lot of times there's good intentions behind it, but fear sells. And you know, I don't buy the whole argument that everybody's going to be out of a job. And there are some people that think that that's a great thing and everybody will be on universal basic income. And I think that's a horrible future. I think people sitting around just getting paid to do nothing and just trying to entertain themselves, it's going to be a very bleak future. Humans need to do things.
That feels like almost like a WALL-E type
it's
of
a
future.
WALL-E thing.
Yeah.
And we don't want to get there. Well, WALL-E did not look like a very happy future to me. We don't want to be there.
Yeah.
And so, you know, I'll hear people talk about, oh my God, you know, we've got these self-driving trucks people are working on. All the truckers are going to be put out of business. And then the next story that you'll hear is we don't have enough truckers, right? There's a epidemic of not having enough truckers because it's a really hard job that people don't want to do and we don't pay them enough. Those things can't be true at the same time. So I think we do want automation for a lot of these things to augment human productivity. So what you can imagine is that we can automate really well the trucks on the highways, the long hours, the long tedious hours. It makes truckers' lives horrible in some sense. Like that's the worst part of it. Like you can't be home. You've got to live on the road. Well, you could have truckers that specialize in, you know, going to the highway entry points and exit points and bringing the trucks through the cities, which is the most dangerous, difficult task of trucking. So you can imagine things like that. And in our demand to move things around, move objects around, if it gets cheaper, it's just going to go up. Who could have thought 10 years ago that you can order a paper towel pack online and have it at your house in one day? Like that would have been you've been like, why would anybody even want to do that?
Yeah.
But people do it every day now. Now, how is that possible? So that would not be possible without robotics. So Amazon, there was a company called Kiva Robotics. Amazon bought them. And what this Kiva Robotics company did is they had robots, really simple robots in some sense, that can roll around a warehouse, pick up pallets from underneath, and bring them to a human that can then take the items out of the box and put them in a package to then be brought by robots to a conveyor belt to be shipped out. That increased the efficiency of the warehouses by a tremendous amount. And that's why you can do things like next day delivery with Amazon. And so this can just be made more and more efficient. So, you know, one of the bottlenecks now is how many of these Amazon trucks can go around neighborhoods, right? There's a limit. You know, the Amazon driver has to jump out of the truck and bring something to your doorway. Well, what if the driver had a whole bunch of robots in the back, sits down in a neighborhood, and the robots just zip around and drop things off in front? You know, that's going to increase the efficiency by a tremendous amount. Very hard problem because it's robots acting in the real world around potentially humans, where you have to be very careful not to injure anybody, especially if you're doing this at scale. But that's how I see things. When the cost of something goes down, which is what technology and real technological innovation does, the demand goes up. That's always happened. And if I'm a betting person, I look at history, and if something has always happened, I'm going to bet on that. the other thing that you'll see if you look at history is every time there's a technological innovation, people will say, oh my, all the jobs are going to go away. And the truth of the matter is there are transitional, there is some turmoil in the transition in some cases, because the fact of the matter is some people will lose their jobs. And that is never great. I mean, it's one of the most horrible things for somebody to lose their job. But there has to be this transition period. And the hope is that with some foresight and some, educational efforts, we can make it smoother to get through that period. But I can't say that there's not going to be some hardship for some people. There will be.
And then, even though we face those hardships, once we get to the other side, it's just going to be better and more automated in the end. That's
what I hope. There are always contrasting opinions, but I think that will be the case. It certainly seems that the automation that we developed, many years ago in the Industrial Revolution has made lots of lives better. We can, otherwise there would be no way we could sustain the population of this planet. The innovations in agriculture, for example, it used to be that 80% of the people worked on agriculture. And if you had asked them back then, you pointed to the future and said, oh, only 5% of people are going to work on agriculture, they would have been like, where is everybody else going to work? And they couldn't imagine what people are doing these days. It wouldn't have made sense to say, oh, some people are going to be podcasters. Some people are going to be trainers in a gym, and like people are going to pay to go to a gym to lift heavy things and be told to do it. Like that wouldn't have made any sense. So a lot of the fear and anxiety is because of lack of imagination or just our inability as humans to imagine the future. So that's sort of how I see it.
Do you think that has to do with just like the status quo and people being comfortable where they're at, and just, I guess maybe part of it is like not being able to see into the future and what could be, but also just such comfortability of what I have right now. Mm-hmm.
Yeah. And especially if you have a job that you're afraid might be replaced, right? So that's a type of status quo that is really hard to argue with, right? Because people need to make a living. And so that's where you can really stoke fear, because that's a very real reality to people. So the status quo is part of it, but also it's really the lack of imagination, right? We just can't imagine what the future will be like. But then once it's there, very quickly humans can turn on a dime. Like ChatGPT, when it first came out, people were calling for a 6-month pause in the development of AI because it's about ready to take over the world. And it's been a good year and a half now, 2 years, and it seems like we're just fine. And now people look at the first ChatGPT and they're like, that thing was stupid. Right? That's garbage. I'm using ChatGPT 4.01 or whatever. And so that's just, humans are very adaptable as well. And that's another reason why I tend to not be as anxious and worried about the future, because I know humans will adapt. They'll find things to do. Their creativity at the moment, once they see a technology and a possibility, it only takes a couple of people to have these ideas and whole industries arise. And so I really will bet on the ingenuity of humans always.
For sure. What do you think? Feel free to, this is kind of like almost a philosophical question, but like, what do you think it is about like the resilience of humans to always kind of adapt to situations? And is that simply like, I guess, what are your thoughts on that?
I think it's innate, built into us. We evolved, and if we did not have that in us, we would not be where we're at, right? I mean, imagine, the humans, when they were in small tribes, hunter-gatherer humans, the resilience that you had to have, right? Just to survive. They weren't worried about philosophical problems at that time. They were just learning how to survive, and just surviving was hard. You have the environment would change on them. other humans would come into the mix and, and change the dynamics of, the resources available. But we always adapt. And it's really an amazing thing. I always think that a human body and a human brain is the most resilient, amazing widget and tool that there is. And because together they can do so much, they're so reliable, so robust, they can be instructed to do anything. And then a few of them, in every generation, have really great ideas and are really good at certain things like organizing other humans and developing new techniques and technologies, mastering fire, mastering, how we deal with steam. It's only a few people that are needed to completely revolutionize how all the other humans operate. So I think that this drive that humans have is just innate. And if we didn't have it, we wouldn't be here talking about this.
For sure. Well, I think we're coming up on the top of the hour. Is there anything that you'd like to promote or plug in terms of your research or anything you're doing right now?
Yeah, I just say, follow what the Dynamic Robotics and AI Lab is doing. We have a website. I'm on Twitter. I'm not a very heavy tweeter, but when we do something new, I will tweet it out. Every now and then I'll point to something that I think is cool. But no, I think, if you're a student right now, it's such an exciting time, right? Don't buy into this doom and gloom of the future. I mean, it's such an exciting time. If somebody's trying to sell you on doom and gloom, don't listen to them. Say, I'm going to do something really cool and really amazing and just get started.
Well, thank you so much for coming on the show. It was an honor to speak to you, and I had a really good time.
Yeah, thank you.